and a cure for type 1 diabetes is a step closer after scientists managed to halt the condition for at least 6 months thanks to insulin-producing cells. Experts from U.S. hospitals and institutions, including Harvard University, managed to transplant cells into mice, which immediately began producing insulin. The team also showed they could prevent the body's immune system from attacking the cells. Experts are now working to replicate the results in people with the condition. And for more on that story, we're joined from Tel Aviv by Dr. Boaz Gildor, geneticist and developmental biologist, and member of the board of the directors of the JDRF Israel. Good evening, Dr. Gildor. Thank you for being with us.
Thank you for having me.
Well, first of all, can you tell us and explain to us what did they find that was so dramatic in this research?
I think before we start, we need to actually understand what type 1 diabetes is. When we talk about diabetes, we actually refer to two different diseases. The one, type 1 diabetes, was formerly known as juvenile diabetes. It's an autoimmune condition, meaning that the body's immune system attacks certain cells in the pancreas. These cells are responsible for secreting insulin, and the disease develops as the body is unable to produce insulin, and insulin is required from outside sources. The two new papers that were published very recently, one in Nature Medicine and the other in Nature Biotechnology, basically they combined two major stepstones in diabetes research. The one is the ability to produce small capsules, only 1.5 millimeters in diameter, from the biomaterials from algae. Now, these biomaterials are very unique in the fashion that they do not encourage an immune response when transplanted in mammals. Unlike other materials that once they are inside the body reacts to it and try to and actually an immune response happens around them.
Yes.
Yeah. The other major step is our ability to or the scientists' ability to grow human insulin-secreting cells in laboratory conditions from human embryonic stem cells. So these cells are allowed to develop on a plate in the lab, and once they start to secrete insulin, they are encapsulated in these microcapsules and transplanted, in this case, in mice. For half a year, which was the period of the study, the mice, although they lacked their normal insulin-secreting cells, were able to retain normal glucose levels.
Yes, Dr. Gildor, it sounds like a hopeful sign for diabetics. We truly hope that it will indeed be a hopeful sign. Thank you for shedding light for us on this extremely complicated issue. Thank you for being with us tonight.